So what we would like to see now is deployments. So one will be a simple NFV-based service design and deployment based on this new fresh installation that George just executed. So by NFV, we're saying that the deployment will go through OSM. What we have right now is a setup of a new installation of release 0 OpenSlice, which is a stable version, and we have an already running instance of OSM. What we would like to have as an outcome is an integration of the OSM instance in OpenSlice, so as to be a candidate orchestrator for orchestration requests, design a specific service based on these OSM artifacts that will be the service will instantiate OSM network services at the end of the day, order this design service for deployment, see how this is deployed via OSM, and at the end of it, execute a simple LCM rule to discover the deployment IPs of the outcome VMs. Okay, so let's start with integrating the OSM instance first. As if I couldn't do that. Okay, so this is the instance that George just installed. And this is, apologies, I would have to go to the NFV portal. So the NFV portal is in charge of integrating OSM instances. As you can see now, the respective catalogs of network slice descriptors, NSDs, sorry, VNFs are completely empty. Same with the infrastructures. So what I would like to begin with is register a specific version of OSM provider, Mano provider. Sorry, platform. It was right from the beginning. So what is this? OpenSlice can support multiple versions of OSMs or Mano platforms that follow the Solo 05. So for this demo, we are relying on OSM 10 installation. As you can see, there are these versions supported. Also, the versions after version 13 also can be supported by this, but they're not thoroughly tested because OSM relies on the same northbound interface. So our installation is OSM version 10. So we add it as a Mano platform to the portal. Now we would like to have the first Mano provider or the OSM instance, as you can see it here, of our orchestrator. So we will add a new Mano provider. This will be OSM 10. Again, the description will be indicative. The supported Mano platform will be OSM 10. This is the platform that we have just created. So we have to differentiate between supported Mano platforms because not all OSMs have the same UI. So we have implemented different clients, NBI, apologies. So we have implemented different clients for the different OSM versions. Then we can register the NBI URL of OSM. In our case, it should be 10.10.10, and the port of the OSM's NBI, username and the password of a specific tenant. And we enable this checkbox here that enables OpenSlice to query OSM for specific artifacts and have them displayed in the respective catalogs, as you can see here. So we need to wait some time, but for this synchronization time to come, but let's browse what is in this admin tenant and what we would expect to see at the OpenSlice portal. So this tenant only has an networks NS package, which is the Hackfest multi-VDU NS, the respective VNF package, okay? And it has also two Vim accounts, Cloudville and Dummy. So hopefully, if I refresh this, not yet. So now we have this synchronization process. So this synchronization process actually follows an interval. So it will take between 0 to 30 seconds to synchronize new artifact to OSM. Someone can upload new artifacts here and see them being reflected at OSM, but this is out of the scope of this demo, but can be supported, of course. So the NSD list is the same. The VNF list is the same as OSM. And also the infrastructures are the respective VIMs, as you can see, Cloudvile and Dummy, with the respective Vim IDs, as you can see, that matches the Vim IDs of OSM. So with this process, we have connected underlying OSM. We can connect multiple instances of OSMs, regardless of their topographic, let's say, location, and we have done it in the past. So a simple instance of OpenSlice can support and control many instances of Manon. Okay, so as we have added this OSM, now I would like to design a service as we suggested. Let me go back to the presentation for the service, and this would be it. Oh, this is okay. And the service we would like to design and to make available to the public is a demo service. This is the name that we will go after this. We will go after. This demo service will deploy the Hackfest multi-VDUNS through OSM. This is a VNF-based network service. This will create two VMs respectively, and two VNFs at OSM and two VMs respectively. And then what we would like to see is how we will discover these VM IPs and make them available to the user without him having access or her having access to the actual infrastructure beneath. So what we would like to see here now is going back to the UI, logging to the service portal, and as an administrator or a service designer, I have I'm in charge of designing the services that will be offered to the customers. So there is a distinction between the service designer and the service customer. Okay, so this action is made by the service designer. So what we would expect to see at the end of the day for a customer to order is add a new service at this catalog for the customer to be able to order. So for this, as a service designer, I would like to import, let's say, I would like, actually, let me rephrase something so as to begin with the right process. This portal, as we've said, the services portal, relies on the service catalog specification of TMF. So every entity of this portal is based on TMF entities. As you can see, as you saw previously, the artifacts that we have synced are not mapped towards TMF. So it cannot be usable by external orchestrators or multiple other stakeholders speaking the TMF language. So right now we have to map these NFV artifacts towards a TMF-based language, which is the service specifications. If you remember by the presentations we had in the beginning of this session, I would say that the NFV-related services or the deployment-related services are actually resource-facing service specifications. And this is what we're going to create right now. So we have automated the process of importing specific NSDs that we find in the previous portal, as you remember, into specific TMF artifacts. So as you can see, with this action here, we have created the resource-facing service specification named under the specific NSD artifact, which is mapped and modeled into the TMF world right now. So what we would like to have for this service, actually, before we go to the LCM rules, let's see about this characteristics table that are actually that is actually being created. So all these were created automatically, and this service has specific service specification characteristics, as TMF calls them, that are actually in charge of delegating the deployments towards OSM. So because this is an NFV-based service, we can find these specific characteristic in the NFV-based service that actually references a specific NSD and a specific Vim account to be deployed. By default, when you import the service, the NSD ID is the one that is delegated from OSM, and the Vim account, by default, is the first that is found for this OSM. For this specific example is the 37AA, for example, which is, as you can see, the first Vim that is added. Of course, someone can change it and deploy it to another Vim. So this is more or less what the TMF, let's say, entity of an NSD-based service looks like. And what we promised is that we would like to have this service exposing deployment characteristics to the user. So the deployment characteristics or the instantiation IP addresses normally comes after the activation of the service. So for this, a service designer needs to create a new rule. It has to be at the after activation lifecycle phase, and it's a rule to expose, let's name it, to expose the deployment IPs. Okay. Actually, before we go to that, apologies for that, I would like to show that someone can create new characteristics. So a service designer may need to create new characteristics so as to enable the user to have something to input when it orders the service, or create placeholder characteristics as this one for specific values to be added. So here I would like to show you two ways of actually exposing these IP addresses. One is for the initial service designer to create a placeholder of characteristic, so VNF IP1. So this is a placeholder that it will host the IP address of the first VM. As you can see, this is added here. And now we would like to design a rule, as we said previously, so that this characteristic, this service text characteristic, let me find it, okay, will be assigned a specific value. This, we would expect, this value will be actually extracted for the VNFR record of OSM. If you are aware of OSM artifacts, when a VNF is being deployed, VNFR record is being exposed to the customer. So this, which has the deployment IP addresses among others and other deployment characteristics. All these models are actually exposed towards OpenSlice, but we would like to abstract all this so it will be straightforward for the user where to find this IP without having to read lengthy JSON files. So for this, we will leverage the VNFR of the first VNF. And for this, we would like to input at the text characteristic VNF IP1 something that we will take out of a JSON value, as you can see here. And the placeholder characteristic for the VNFR of VNF1 is this one. This characteristic is also being created automatically because the service actually tracks that this NSD will create two VMs. So I would say that in VNF IP1, I would like to have a specific value from this VNFR, which is available after activation. And now we would like to define at which point of the JSON this value will be found. So we expect that the VNFR, or the service designer would expect that this VNFR will have at the first level of the JSON provided this property. So the VNFR has IP address as a high-level property, and this is what we would like to see at the VNFR IP1 characteristic. So another way to create characteristics, if we haven't predefined them, as you can see, is by explicitly creating new characteristics, as you can see here, with the respective name, DNF IP2 this time. And for this, I would like to have the same thing, so you can copy the above code, but not for VNF1, but rather for VNF2. So this is a rule. Actually, we haven't have the time to introduce the rules, but as you can see, the dynamic rules is not code itself, so you are not programming, but you are using this block-based language, which is Blockly by Google, to graphically define rules. So this is a quite simple rule, but you will see something more complicated in the next session, which is the actual 5G as a service deployment. So this is an after activation, and we expect to have these two IPs exposed. So this is the resource-facing service. This cannot be exposed to the customer. So what we have promised is that a customer needs to have a nice and friendly customer-facing service to order from. So what we would like to see is a demo service, as we've seen, as we've named it, with the same description. Let's say this supports Markdown, so you can have whatever description you like. So submit, you create a new specification, and we need to assign, as you can see, this resource-facing services that we have been defining prior. We need to assign it to this customer-facing service. For that, we need to go to that tab, but it prompts us that the service specification must be considered as a bundle in order to assign relationships. And this is why we need to do that. And now we can assign services to be executed. So if we had many services here, we could assign more services to simultaneously be executed when this customer-facing service, demo service, was ordered. So right now we have a simple service to be instantiated. And now, having designed this user-friendly service, I would go to the respective catalog of generic services, which is this one, category rather, edit it, and I would add, apart from this one service that is exposed here, also the demo service. So right now, the service designing process has ended. So a user would expect, now I'm not logging in as a simple user, but it's the same, so as to save some time. So let's say a non-admin user could log into the portal and actually see this service right now, which wasn't present previously, and order it. So preview, could order it, also check some characteristics and see if you can define some user-defined ones, but in this case, the user can't. Place it in order list, review the order list, and assign them for deployment. So by default, this starts the deployment, or the service ordering starts from today, now, the time now, and lasts for 1 day. Of course, this can be changed. So the user will order the service, and we could expect that an administrator then would log in again. But again, for simplicity, I'm staying with the same user. Will review the service orders. So an administrator receives a notification that a new order actually was made. Review the service order list. This is the new. Review the service order and what it was supposed to execute. And if it finds the execution agreeable, then it can change the initial state to acknowledged, meaning that this order can be now processed and be ready for deployment. And from now on, everything is automated. So we just need to wait and see this service being deployed at OSM. And after the activation of the service, we will see the VNF IPs as promised. So what happens now is that the service orchestrator is calling for, as you can see in the stage, for acknowledged orders, and actually tries to process them as soon as they arrive. So as you can see here, we instantiated the demo service, which in the respect instantiated Hackfest multi-VDU NS at OSM 10. Let's see it as we wait for the deployment. Let's see what happened in the presentation. Okay. So the user orders a demo service, as we've said. So what we expect to happen is that throughout the demo service deployment, the user can preview what's happening, as we have seen. So the demo service will be in charge on deploying this specific network service at OSM that will reside, that will actually come to the deployment of two VNFs inside OSM environment and the respective VMs and the cloud environment that lies underneath OSM. So what we would expect to see after this, after the deployments are actually active, is a closed loop or a rule execution after the successful deployment that acquires the deployment IPs from the records of the deployed VNFs and exposes them to the characteristics that we have just created prior to this deployment. So let's check what's happening behind the scenes. So OpenSlice still says that the resource-facing service, which is the instance of the resource-phase specification, is on reserved mode and is currently in progress. What we would expect to see if we go at the OSM is to see an instance of this service running. And as we can see, this instance is already marked as operational. So the service order maps the service order, which is automatically assigned, as you can see. The VNFs are ready at OSM, both of them, and we would expect shortly that also these changes will be reflected at this UI. As you can see, OSM marks that this network service is active. As we have a polling interval on NBI of OSM, we might experience some minor delays in terms of when the OpenSlice will be notified about the activation of the services. This is because of the restrictions of the NBIs that doesn't support callbacks. So this is a restriction that we cannot avoid if we're saying about deployments through OSM. So as you saw, the resource-facing service, which represents the network service on OSM, went to active. And what we expect to see is that the overlay customer-facing service will also be active at the end of the day. And then just like now, and the order will be marked as completed in the next tick. Now, as we wait, we were actually expecting that the customer that sees that thing would expect to see the promised VNF IP addresses. And if he or she clicks the respective service, which is this one, and goes to the service characteristics, it can see some characteristics that maybe doesn't make sense to an experienced user, but we'll also see the VNF IPs that derived from the LCM rules after the activation of the service. So these are the two deployment IPs of these VMs. So this is the first demo. And of course, this is actually operational right now, and it will last until 1 day, as the initial, let's say, service time was requested. But someone, sorry, this is a service, but someone can prompt this service order tear down earlier and terminate it prematurely before the, let's say, the state is completed. Actually, I'm not quite sure if this was accepted. Okay, so this was the first demo. If we didn't do, let me just, I think the UI refreshed as I did it. Yes, now this is correct. So I just prompt the service to tear down earlier than expected. This can happen, or the expected, let's say, date, they can also be expanded through the UI. So what we have prompted right now is for the service order to be terminated prematurely. So this will turn the respective related services into terminated mode, and this will prompt the respective action towards the service at OSM. So at the end of the day, we will see this service tearing down. So not to waste some time, I will just keep with the admin tenant. As you can see, we can come back later, most probably, because we have the most interesting demo of today following through. So as you can see, the services are terminated, and respectively, this order will be terminated as well. So I will leave it as is, and we can come back later and check it.